Once we complete this section, you should be familiar with how to display and interpret the permissions set on the files throughout the file system. File permissions are in place to control access of who has what to various parts of the directories and files throughout the operating system. We'll want to make sure that we keep things as secure as possible, but we never want to inhibit appropriate system interactions, and the application permissions allow us to do exactly that. There's three main categories in which files have a permission set on them. The first is the file's owner, or the username that's associated with ownership of the file. The second is the group owner, or group name associated with the file's ownership. And lastly is everyone else, or other. More precisely, everyone else or other is neither the username that owns the file or any of the members of the group. We shortcut these abbreviations to U for user, G for group, and O for other. When a user falls into more than one of these categories, the most specific designation takes precedence. For example, if you're a member of the group that owns it, that would be your most significant precedence. If you were also the user who owns that file, the user permissions would override the group membership. Have a look at this diagram. In this diagram, we have two users, Joshua and Allison. Allison belongs to the Allison group as well as the wheel group, while Joshua belongs to only the Joshua group. A group named Web can be created, and both Joshua and Allison can be added to this group. This would allow a collaborative way to have files owned by the Web group allow access to both the Joshua and Allison user for access. In this way, you can design out the groups added to your environment and supply the members into each of those groups that facilitate the workloads required in your own environment. As we go forward, we'll take a look at some of these permissions, but before we do, we need to understand what the specific permissions are and what each permission means when it's applied on a file or directory. The first permission to discuss is the R permission for read. When we're talking about a file itself, that means that the contents of the file can be read or displayed to the screen. When we're talking about a directory, that means that we can list out the contents of the directory or the file names contained within that directory. The next permission is W. This is short for the write option. When a file has the W permission for your particular access, that means that the file contents can be changed by this user. When we're talking about the write permission on directories, that means that any file in the directory can be created or deleted from that location. The last permission is X for execute. When this is for a file, that means that the file can be executed within commands. This should be reserved for only files you intend to have executed output within the environment. When we supply the X argument or X permission to directories, that means that the directory can become your current working directory, which means that you're allowed to use the cd command to change into it, but also it will require the read permission to list files found there. It's not uncommon for a user to have both read and execute permissions to read-only directories. This allows them to view the contents of the file and execute it if it's a script of some sort or a command. Extending the write permission may not be appropriate in those instances and is oftentimes omitted. Files and directories may be removed and altered by anyone that has the proper permissions to write in those locations. It's always important to assess who has write privileges in your files and directories to make sure that only those who have appropriate access are properly set up. We do have a special permission, known as the sticky bit, which will allow us to override this behavior, but we'll discuss that a bit later.